Hi, in this video we are still going to look at graphs or functions. But before I move on to that, let me apologize for what I said last time. Dogozwea, you are from Orange Farm, and Bandile, I suppose you are from Porky. I think I made a mistake. So today the function that we are going to look at is a hyperbola. You've looked at hyperbolas before in grade 10, and then the hyperbolas were graphs that look something like that or like that. What's good about these functions is that they've got these solid lines which are not joined. So this is one graph, it's got these solid lines, but there's also these dotted things which are called asymptotes. So this one is a vertical asymptote, that's a horizontal asymptote. There's another graph, vertical asymptote and a horizontal asymptote. If this is a line, you should have an equation. To find the equation of this line, you just solve for x there. So x minus p equals 0, so x will be equal to a p. So that would give you the equation of this line. If I want to find the equation of this line, it's just y is equal to q. So the equation of this dotted line will be y is equal to q. However, this is the graph. But where do we put these graphs? These graphs, you put them on a Cartesian plane, on the x and then y axis, x and y axis. If a is positive, meaning if a is bigger than 0, if that number over there is a positive number, say for instance it's a 4 or 2/3 or whatever positive number you may think of there, so your graph would be placed on the Cartesian plane and it would be something like that. Now, if a was smaller than 0, or a is a number which is negative, so your graph will look something like this. What I like about these graphs is that these graphs can move up or down. Note that when it moves up or down and down, the horizontal asymptote also moves. Even if it goes right or left, the horizontal will also move. This is because you may find yourself being asked to draw a graph where the graph might have moved up and also towards the left. At the end, you will find that you'll have to draw, or you have drawn a graph that looks like this one, where that is the horizontal asymptote, and we said the horizontal asymptote has got an equation which is this line, that number over there. So that will give you an equation of this dotted line. So the equation of this line is y is equal to q. That is a horizontal asymptote. And to find the equation of this dotted line, you use x minus p equals 0. So x minus p equals 0, and you solve for x. So x will be equal to your p. So that's the equation of that vertical asymptote. So let's look at some examples. Let's say this is example 1 that you had to draw. You had to draw the graph of y is equal to 6 over x minus 2 plus 1. Obviously, there are things that we already know. That we said that one there is our horizontal asymptote, which is from there. So which means in our graph, we'll be having something like this. Another thing is this one here, which will help us to find the vertical asymptote. So the vertical asymptote will be line going like that. When we solve for x, from this we get x minus 2 is equal to 0, so x is equal to 2. So which means that the graph or the dotted line will be on the line x is equal to 2. And then x is equal to 2 is on the right of the 0, so I can say x is equal to 2 on this side. Another point that we have mentioned was if a was a positive number, the arms will be like this. If a was a negative number, then the arms will be like this. Note that a there is a positive 6, so which means that the arms will be exactly like this one. So our arms will be somewhere there and somewhere over there, which therefore means that our graph won't cut, that part won't cut, but this part here will be now cutting the x and the y axis, which means that we will have the y-intercept and the x-intercept. We'll have to work out that. Now, let's try and fill this thing in. So they said, what is the vertical asymptote? Our vertical asymptote was the line that goes through like that, and we worked it out as x is equal to 2. So the equation of this is x is equal to 2, so the vertical asymptote is the line x is equal to 2. The horizontal asymptote, we said it's a line that goes like that, and we said it's that value of q, which in this case was 1. So the equation of this was y is equal to 1, so our horizontal asymptote is y is equal to 1. Now we need to work out the y-intercept. Just as before in our previous examples of parabolas and straight line graphs, y as an intercept is when x is equal to 0. The y-intercept is where the graph cuts the y-axis when x is 0. If I'm given the equation y is equal to 6 over x minus 2 plus 1, when x is 0, we'll get the y-intercept. Now let's try and find that. So y is equal to 6 over 0 minus 2, because we said in the y-intercept x will be 0, then plus 1, which was a plus 1. So if I solve this, I get y is equal to 6 over 0 minus 2 is minus 2, then plus 1. So y is equal to 6 divided by minus 2 is a minus 3, then plus 1. So y is equal to minus 3 plus 1, that gives us a minus 2. It means that the y-intercept of our graph is minus 2, meaning that our graph will cut the y-axis when y is minus 2, and y is minus 2 below the 0 there, so maybe the y-intercept is somewhere there. Let's make a point there, so we know that our graph will cut there at minus 2. Put a minus 2 there. The next one is to find the x-intercept. The x-intercept is where the graph cuts the x-axis. So where does the graph cut that x line? So find the x-intercept, we always make y 0. If I'm given the equation y is equal to 6 over x minus 2 plus 1, we make y 0. So if we make y 0 there, so I will have now 0 is equal to 6 over x minus 2, then plus 1. And then I try and solve for x. So I can solve for x by taking this to the other side. So this to that side would give us a 0 minus this, which will be minus 6 over the x minus 2 is equal to 1. Now then I need to solve for x. What do? I can cross multiply. So this x minus 2 will multiply there. So I'll have a minus 6, which equals 1 times the x minus 2. So which minus 6 is equal to 1 times that is x, 1 times that is minus 2. Which therefore means that the x value is equal, take minus 2 to the other side, it will be minus 6 plus 2 will be minus 4. So the graph cast the x-axis, or it has an x-intercept when x is minus 2. When x is minus 2 is on the left of x of 0, so which means that I'll have maybe a point over there. So my graph will be cutting there and there. Remember that we said our graph will look something like this with the dotted lines. So it will be something like this. I will put and draw the graph over there. So my graph will look something like there. And we'll have another arm over there. So we do have the shape of a graph. Then the next question that they are asking us, they are saying here, what is the domain? Now note that the domain are the x values of the function. We can see that our graph is getting closer and closer towards our vertical asymptote. The graph will never cut the asymptote in this case. So it means that the graph cannot be 2. Even you can see here is coming closer and closer towards our vertical asymptote, which means that the graph cannot be equal to 2. Therefore, we can say that the domain of this can be any number except when x is 2. So we'll say the domain is any number. X is an element of real number, meaning all the numbers, the real numbers, but we say that x cannot be 2, so we say x is not equal to 2. That's it. What about the range? The range is about the y values. The y values that a graph can take. If you look at our graph here, it goes up, 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 but when it reaches that dotted line, it doesn't touch that line y is equal to 1. Even when it comes down here, it's not going to touch our dotted line here. So which means that that range of this graph are all the y values except y equals 1. So the way we write it, so the range is y is an element of real numbers, all real numbers, but y cannot be equal to a 1. Let's look at another example. Another easy one. Sketch the graph of y is equal to minus 8 over x plus 1 minus 2. Again, we said if the graph has got a which is less than 0, which could be minus 4, if that number is less than 0, so say minus 4 or what, so the arms will be somewhere like this, which means that our arms for this graph will be, one will be there and one will be there. But remember that we said our graph though can move left or right like that, but basically the graph will be in that position. Okay, then the next thing that we get is that they say we've got a minus 2 there. What does this minus 2 tell us? It's telling us that that's the value of q, and we said the q is our horizontal asymptote. So we know that our graph now has got a horizontal asymptote down there. The next thing is that I can find the vertical asymptote. To find the vertical asymptote, we solve for x there. So if we are to solve for x here, we say x plus 1 is equal to 0. So I get x is equal to minus 1, which means that our vertical asymptote is on the minus 1. So it means that the graph has also moved something like that. So which means that we've got a shape of a graph which looks like that. So we can try and fit these things in because it looks nice. Let's check on it. So if we can put that dotted line which was vertical at minus 1, so we've got a minus 1 dotted line going vertically, that's a vertical asymptote, and then the horizontal asymptote which we said was at minus 2, so we've got it like this. And therefore we now know that we saw that the graph is something like that, so it can be like cutting something like this, which means that our graph would be doing something like that and also doing something like that, which therefore means that our graph has an y-intercept over there as well as the x-intercept over there. And now we know how to work out the x-intercept and the y-intercept from the previous example. To find the y-intercept, we said find the y-intercept to make x 0. If x is 0, therefore I will say here I've got y is equal to minus 8 over, now put 0 for x, 0 plus 1, then minus 2. So y is equal to minus 8 over, and then the 0 plus 1 gives you 1, so minus 2. So then the answer will be equal to minus 8 divided by 1 is minus 8, minus 2, that is minus 10. So our y-intercept is minus 10, which means that where the graph cuts the y-axis, it will cut at minus 10. There is minus 10, which cuts the y-axis at minus 10 over there. The next one is to find the x-intercept. We said to find the x-intercept, we make y 0. So if I make y 0, or I place 0 there, so I'll get 0 is equal to minus 8 over x plus 1, then minus 2, and then try solve for x. So if I take this to this side, note that there is a minus, then I take to the other side, it becomes a positive 8 over now x plus 1, which is equal to minus 2. And then now I can try and solve for x. How do I solve for x again? I can cross multiply, take this one across there, so I'll get 8 is equal to minus 2 times, because I'm cross multiplying, times 1 x plus 1, and then I can remove the brackets. 8 is equals to this, and this is minus 2x, and minus 2 times a positive 1 is minus 2. Solve for x. Take minus 2x across, this positive 2x is equal to, there is a minus 2, take a plus 8 to the outside, that's minus 8. So 2x is equal to minus 2 minus 8, that is minus 10. So divide both sides by 2, I get x is equal to minus 5. So our x-intercept is when x is equal to minus 5. There is with our x-intercept there at a minus 5. Then the next question that is asked now here, they say, can you give us the equations of lines of symmetry? Now, to think about the lines of symmetry is you've got to look back and check what your graph looks like. If we go back to our graphs, basically they look something like this. They're something like this. If you look at this graph, I can fold this thing here like this, across like this. When I fold, this other side will lie exactly on top of the other, which means that I've got a line here, imaginary line, which I will call the line of symmetry. So if I fold along that line, this arm will lie exactly on top of this. So I can draw that line and say something like that, and that line there is the line of symmetry. There is another line of symmetry, of course. If you take this other example, if I like, I would have folded like this, so that that piece lie on top of that, so it's like this, and therefore the line of symmetry will be like that. Remember, we said we could have folded like that again, so I can have another line of symmetry like that. So the lines of symmetry, we've got two equations for the lines of symmetry. The ways of finding the lines of symmetry is just to remember this. If the line is like this, you can see it's a line going through like that, so your equation will always be like this. Y is equal to, all right, that's a positive gradient, so I'll put a bracket, then I say x minus p, then plus q. I'll be able to find the line of symmetry. Note that's positive, so I put a bracket like this. Now let's check where this x minus p comes from. It's exactly from there. It's x minus p, but remember, put the brackets, then plus a q. Because long time ago, that line was called a bracket. It was called a vinculum. Now we no longer use the term, so it's vincular. So it's a bracket there, so that's in bracket, so a bracket there plus a Q. Now let's look at this one over here. So this one here has got a line going that way, which means that the gradient of this line is negative. Therefore, the equation would be y is equal to a negative. Then you put the bracket again as you did there. So it's x minus p, then a plus a q. So if we go back to our example where they want us to find the equations of the lines of symmetry, so we will know that the lines of symmetry, so one line of symmetry will go something like this. Like that, and then the other one will go something like that. And we said if the line goes like that, so the equation of that one will be y is equal to, we'll put the bracket is x minus p, then a plus a q. So if it goes like this, we'll say y is equal to, put a bracket minus first, then it's x minus p, then a plus a q. Now let's try and put the things in here. So the first one is y is equal to a bracket. So it's x minus p, then plus a q. Let's put the values for this from the equation. So here in this equation, it was that. So the x minus p is x plus 1 here. So I'll put x plus 1, then minus 2. Then I can simplify this. I get y is equal to, remove brackets, is x plus 1 minus 2. So y is equal to x. Those are like terms. So 1 minus 2 is minus 1. So that's the first equation that they are looking for, is the equation of this one over here. The other one is that one which is going that route. It's got a negative gradient. The other one will say y is equal to minus, as we said, we put a minus, and then open the bracket x minus p, then plus a q, and therefore y is equal to a minus, then you open our bracket is x minus p, but the thing which is inside the bracket is the x plus 1, so this just say x plus 1, then that minus 2 minus 2. Now remove bracket, so y is equal to, this and this is minus x, this and this is minus 1, then minus 2. So y is equal to a minus x, then minus a 3. So the equation of this one is y is equal to minus x minus 3. Note that this is a rough sketch. You can see that it's cutting in the wrong place there. But anyway, this was a rough sketch, and that's an equation. So if you don't mind, you can just try these few examples for yourselves from your textbook, the Siavula Maths book, grade 11, chapter 5, exercise 5.14, numbers 1, A, B, C, D, and E. It's easy as that.